You found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube, the Dapper Dinosaur here. Today we're going to talk about one Dr. Jake Hebert. Now, he did indeed earn a doctorate, having a bachelor's degree in physics from Lamar University, a master's in science and the same from Texas A&M University, and a doctor of philosophy, again in physics, from the University of Texas at Dallas. I think it's sad that it always feels like I have to check with creationists, because so often they either don't have the degrees they claim, or their degrees are irrelevant. And yes, getting a degree from an unaccredited school is the same as not having the degree in question. It's just more expensive than the normal route people go to not get a degree. That is, just not trying to get one. Dr. Hebert is giving a talk on the age of the universe at an Institute for Creation research event, and it's mostly about space stuff. I like space, as you might already know. So let's get to it. Dr. Hebert, the floor is yours.
This morning, I'd like to talk about our universe and its age and the evidence for creation.
Ooh, evidence for creation. Is it about to happen for, the first time ever here in this talk? We shall see.
Now, if you go out into the country, far away from the city lights, and you look up on a dark night, you see all these beautiful stars, and it is very easy to affirm what King David wrote, that the heavens declare the glory of God, and the firmament or the expanse shows his handiwork.
Hey, if a view of the night sky out on a country road miles from civilization fills you with awe, good. It should. It's fine if it inspires a spiritual experience, but ultimately this is just look at the trees, except it's look at the sky. It's still not an argument.
But we're being told that that's not the case. We're being told that the universe is not God's handiwork.
By whom? Certainly science doesn't have anything to say about whether God created the universe, just that if there is a God, and that God created the universe, it was done via the Big Bang. Now, some scientists might be saying that there is no God, but that's not the same thing. In fact, famously, the atheist Fred Hoyle hated the Big Bang, even coining the term as a pejorative, because he felt that the universe as we know it, having a beginning, was too reminiscent of Genesis.
But rather is the result of an explosion of sorts, and I put that in quotes because it's not a conventional explosion.
I sincerely appreciate that.
But it is an explosion of sorts called the Big Bang. And the Big Bang has lots of problems with it. We could spend an entire talk just on problems with the Big Bang.
See now, this is sneaky. What does he mean by problem? Do we have unanswered questions about the Big Bang Theory? Yes, we do. The crisis in cosmology is a big one, where various ways of estimating the age of the universe give different answers that are all outside of each other's margin of error, meaning that there is some aspect of the theory that is either wrong or incomplete. Do any estimates come within even 5 orders of magnitude of allowing for a date that would be compatible to young Earth creationism? No, of course not. To put it in other terms, this is like scientists arguing whether the moon is 3,745 kilometers in diameter or 3,875 kilometers in diameter. And then creationists come over and say, yeah, but maybe it's less than 40 meters across. Is there anything that indicates the universe was not hotter and denser going back in time to a point where the current observable universe was essentially all coextensive at some beginning point for our little region of spacetime? No, nothing at all. Creationists like to pretend that any disagreement in science somehow negates the evidence which is not disputed. Ooh, there's a disagreement about where in the phylogeny of hominins Homo sediba should go? Guess evolution is fake. Oh gee, it's not clear why a particular antibiotic kills bacteria? I guess the germ theory of disease is fake. Oh, Mercury isn't following Kepler's laws perfectly? I guess gravity is fake. Oh, is there some disagreement about how many billions of years the universe has been around? I guess the Big Bang is fake. Yeah, that's not how science works.
One of these problems is they have a hard time explaining the origin of stars.
Sufficiently cold gas and dust can gravitationally collapse to the point that gravity can overcome any outward pressure from internal gas pressure and radiation pressure. Further, humans have observed every stage of the birth of stars, from collapsing nebulae to protostars to stars beginning fusion, all the way to full main sequence stars.
Now, they do have an idea. They do think that stars form from these giant gas clouds.
Yeah, because that's where humans are seeing protostars and protostellar nebulae collapsing. But who cares about that, am I right?
And the thinking is that if you can have this shock that can compress this gas sufficiently, then gravity can take over and you can have nuclear fusion begin.
That skips over a few things, but yes.
So what causes these shock fronts? Well, one of the popular ideas is that it's coming from an exploding star. Okay, so basically they need stars to form new stars, but that obviously raises the question, where did those first stars come from?
Good question, but I suspect that Dr. Forehead actually knows this. You see, the Big Bang at the earliest moments was a time when the scale of the universe was so small that the universe-wide structures were affected by the strangeness of quantum mechanics. You may know that quantum mechanics uses a lot of the math of waves. This wave-like structure permeated the whole universe because, again, the universe was small. As a result, there were differences in the density in various regions of space. This set up what are quite literally sound waves, meaning that there were in fact pressure shocks early in the universe's history. That's what disrupted the gravitational equilibrium in the gas clouds of the earliest universe, allowing some of them to collapse into stars.
Okay, and there's lots of other problems with this thinking as well.
Lots of other problems? What was the first one?
A critical part of this Big Bang story is that the universe is unimaginably old. They would claim it's almost 14 billion years old, and yet Scripture teaches that the universe is young, roughly about 6,000 years old.
No, Scripture doesn't teach that. Young Earth creationists do. They do not have a monopoly on the interpretation of biblical texts, nor are people who do not find that the Bible is saying that simply being dishonest about it. There are myriad interpretations of Genesis from both Jews and Christians that are all held sincerely and in earnest, that do not agree with the young Earth interpretation. Further, even if that were the universal conclusion of Bible interpreters, it wouldn't make the universe 6,000 years old. It would make Genesis wrong. The universe existed before the Bible, and the Bible depends on the universe to exist. Physical reality is the standard by which claims about physical reality are to be tested. Any idea that is flatly contradicted by physical reality is simply wrong. Young Earth creationism is such an idea, regardless of what the Bible has to say.
And naturally, people wonder, well, is the Bible wrong? Is the Bible wrong about the history of our universe?
Only in so much as it is interpreted in a way that makes it claim a young age for the universe. But don't worry, the Bible can also easily be interpreted to say that the earth is flat, and that it is the center of creation, and that the sky is a solid dome with windows or gates in it to let in water, that genetics works by sympathetic magic, and that pi is 3. But somehow Christians have managed to get around all of this, and stayed believing Christians. Most Christians have done the same with the age of the earth, but for some reason, young earth creationists have decided to die on their cherry-picked hill of the age of the earth and special creation.
Well, I'm here to assure you that it's not wrong, it's absolutely correct.
A tall order.
And I want to reassure you that recent creation is reasonable.
That word reassure is very appropriate. You see, creationism isn't really about science, gaining knowledge about the world, advancing technology, etc. It's about keeping the already convinced within the fold. It isn't even about convincing others, as basically no one is convinced of a young earth and special creation on the basis of the evidence for them, and then happily finds that those ideas were always compatible with Christianity. People convert to Christianity for other reasons, then decide that their theology is more consistent or more in line with their hermeneutical principles if they become young earth creationists.
The popular media, and I guess you could call it the big science establishment, wants you to think that if you hold to a recent creation, you're committing intellectual suicide.
I don't know if I'd go that far. You can be a young earth creationist and do perfectly well in many fields, from literary criticism to electronics to burger flipping. However, it is also the case that once you believe in one conspiracy theory, and make no mistake, this is a conspiracy theory, you are more likely to buy into more, which is why creationists also tend to be anti-maskers, anti-vaxxers, fans of essential oil therapy, etc. Those things are dangerous.
That there's no way that any reasonable person can believe that the universe is just a few thousand years old.
Sure there is. They can have been told that by people they were misled into thinking are experts on the matter. We all have to trust those better informed than us for many things. I don't know much about cars, but if the mechanic says a car has a busted transmission, then I'm probably going to believe him or her. If a chemist tells me that mixing 2 different cleaning products is potentially fatal, I'm not going to test it myself. That some people are lied to by the likes of Hebert, Carter, Sanford, or Snelling isn't their fault, nor is it an indication of stupidity or other intellectual deficiency. Now, what is the case is that no one who has investigated the question themselves can reasonably come to the conclusion that young earth creationism is true for evidential reasons. They can only use non-evidence-based reasoning to come to that conclusion. Now, if your epistemology is based on empiricism, then yes, it is unreasonable to come to the conclusion of a young earth based on the evidence. If you have some other epistemology, then it might work out, although many such epistemic frameworks are themselves pretty unreasonable.
But I want to assure you that's not the case. First, science cannot prove that the universe is old or young. If you're looking for a slam dunk, airtight argument from science that the universe is old, we can't give it to you.
In the sense of mathematical, unassailable proof, that's true. In science, conclusions are held provisionally on the basis of statistical analysis of data. Generally, in physics, in order for a measurement to be considered valid, the measurement must have a confidence interval of 5 sigma. That corresponds to a 0.00002% chance that the data was the result of a fluke rather than an actual physical effect. It's a bit simplified, but this means that while we can't say for certain that the universe is billions of years old and started in a Big Bang, the chances that it is and did are basically 99.99998%, or 1 in 50,000. And given that this is based on numerous observations, each of which compounds, that number quickly gets bigger and bigger. For example, just 2 5 sigma observations that both corroborate a particular conclusion brings the chances that it were a fluke to 1 in 2.5 billion. And there are thousands of such observations supporting the basic story of the great age of the Earth and the universe and the Big Bang. So, at what point does this get to 100% surety? Well, never. But when the chances that the mainstream scientific view is wrong can only be expressed with 10 raised to the power of 10 to the power of some huge number, well, it's pretty silly to say that maybe it's wrong. In fact, there's a reason why no one has ever bothered to try to calculate a single confidence interval for the basics of the Big Bang. The chances are so high and the observations so numerous that it's so likely that giving a definite number is probably impossible.
And the reason for that is really pretty simple. It's because age isn't something that's measured in a laboratory.
That's just a lie. It's generally measured directly, but then many things are not measured directly. When someone puts a sample in a spectrograph to see what elements are in there, they aren't sorting atoms by hand and putting them into piles counting as they go. They're measuring emission spectra and using that to determine the composition of the sample. When someone uses trigonometry to measure the height of a mountain or a building, they're not holding up a ruler to the mountain or building. They're measuring angles. The fact that age is calculated is in no way a problem, nor does it mean it's not measured. This is an actual flat earth argument. Flat earthers will say things like that measuring angles isn't measuring distance, as if the two were unrelated, or that measuring the deflection of a torsion bar isn't the same thing as measuring the force of gravity. The age of the universe and parts of it are routinely measured, but it's not a direct measurement. It's measured by things like redshift analysis of the expansion of the universe, and for parts of the universe, things like stellar spectra and radiometric dating. It's fair to argue that any of these doesn't work and then give reasons, but to simply state that age isn't measured is a lie. Dr. Hebert has a PhD in physics, and he knows better.
Every time a scientist talks about an age or an estimated age of a rock or anything like that, these are calculated numbers based on assumptions about the past. We weren't there in the past, okay? So we're having to make these assumptions, and those age estimates are only as good as the assumptions behind them.
But what do we mean here by assumption? Well, in science, there are really only 2 axiomatic assumptions: that the physical universe objectively exists with measurable properties, and that the rules by which it operates are basically invariant with respect to time and space. What are called assumptions in a given experiment are actually the conclusions of previous science. So, for example, when measuring what atoms are present in a sample in a mass spectrometer, the emission spectra of various elements are assumed. But those spectra were first established by prior experiments. They weren't just picked out of a hat. Similarly, when radiometric dating is done, the decay rates of the nuclides in question are assumed, but that's because such decay rates have been both measured experimentally and calculated from the basis of particle physics, which itself has been validated experimentally. Science builds upon itself. As it has been said, we stand on the shoulders of giants. Everything those scientists did before us that has stood the test of time does not need to be redone unless there is a problem, and can, in the absence of such a problem, be used as the basis for new science, with the prior conclusions serving as assumptions.
Now, creation and secular scientists have different starting assumptions. We affirm creation and a global flood.
The global flood is demonstrably not a thing that happened. Properly basic assumptions should be restricted to those necessary to begin reasoning and investigating, and generally should not be something that could be evidenced or contraindicated. Now, I'm not going to get into whether a belief in a transcendent being as the ultimate cause is a reasonable, properly basic assumption. Now, what I can say is that the literal truth of the Bible is absolutely not a properly basic belief. It is not required in order for reasoning about the world, and neither is it self-evidently true.
But secular scientists deny those things. Now, secular scientists will disagree about a lot, but they are all adamant that God did not make the universe in 6 days, and there was no global flood that destroyed the world in the days of Noah.
Yeah, well, scientists are usually pretty dead set against things that not only have no evidence, but that have literal mountains of counter-evidence. And when I say literal, I mean literal. There are actual physical mountains that could not exist if creationism were true. In fact, I would hazard to say that other than some recent volcanoes, that's basically all mountains.
That's one thing they all agree on. And they hold to a philosophy called uniformitarianism, which can be summarized by the motto, "The present is the key to the past."
Uniformitarianism is a principle in geology, and it's one that's not strictly adhered to. It is related to, but distinct from the basic assumption in science that the way the universe operates is fundamentally invariant across time and space. Uniformitarianism says that rocks that formed in the past formed in ways that we can see them forming now, and that catastrophes played more or less no role in the history of the geology of the Earth. This is not how modern geology operates. Instead, it uses actualism. This acknowledges that catastrophes have occurred, like supervolcanoes, large-scale floods, earthquakes, asteroid impacts, hurricanes, sharknadoes, etc. But it also says that the physical processes which formed rocks in the past are investigatable in the present, and that we must use known mechanisms to explain rocks. Or if none can explain a rock, a mechanism must be investigated in the present. So this idea says that yes, the scablands of Washington state are a gigantic flood spillway, and also yes, the White Cliffs of Dover took at least hundreds of thousands of years to form, because in both cases it's physically impossible for some other mechanism to have formed them. Uniformitarianism is not an idea in astrophysics, cosmogony, or astronomy. However, those fields too follow the basic assumption of science that physics today is physics yesterday.
And so they would claim that the processes we see going on today, operating at more or less the rates and intensities they do today, are sufficient to explain Earth history.
That is incorrect. We have never seen in human existence a volcano as strong as some of the ones of the past, or an impact as big as the one that ended the Cretaceous. No one alive since the advent of science has seen a flood as big as the one that washed across Washington state. Rates and intensities are well known to vary by geologists, but they have to do so within physical parameters, and some rates and intensities are known to have boundary conditions. For example, if you want to build a mountain through folding like the Himalayas, you can calculate how much energy it would take fairly easily by just using the mass displaced and the distance it was moved. That gives you a number in joules. Now you can work out how much power that would take by simply figuring out how much energy was used per unit time with various assumptions for the time frame. Turns out that if you build them too fast, that amount of energy would just melt or even vaporize the rock you're trying to fold. Long before that, however, the rocks would noticeably metamorphose, which means it can only happen so fast. Similarly, there are known maximum rates for things like the deposition of silt or organic lime, and since there are no known physical mechanisms to accelerate them beyond these, there are minimum ages for formations made of siltstone or organic limestone. In order to invalidate these things, creationism would need new physics, which ironically was basically the conclusion of the radioisotopes and the Age of the Earth team, a group of creationists who set out to provide scientific backing for the young age of the Earth. Amusingly, while they claim success in their report, if you dig deeper, it turns out that the only way they could support their conclusion was by simply assuming numerous miracles, such as one, to accelerate the nuclear decay, and another, to get rid of the absurd heat that their idea generates that is sufficient to vaporize the crust of the Earth, and yet more to do things like shield all living things from the intense ionizing radiation all this accelerated decay would cause.
So if you apply uniformitarianism to geology,
which no one really does, strictly speaking,
a geologist would say, well, erosion is slow today, therefore it's always been slow.
Blatantly incorrect. Erosion is not always slow today, and evidence of rapid erosion is acknowledged in the geological past. What the geologists will say is that if you want to posit erosion that breaks the laws of physics as we know them today, such as to allow for the Grand Canyon with its barbs, meanders, and switchbacks, to be formed from a flood runoff in the last few thousand years, then you're going to need to demonstrate those new physics. Or you should be ignored. Turns out the creationists so far have not come up with new physics to explain the geology of the Earth, and that same geology is well explained by real science already. So there's no reason for any actual scientists to go looking for such physics as of yet.
And they would argue that it took millions of years for the Grand Canyon to be carved out slowly and gradually.
Yes, they would, because geologists know what rapid catastrophic flooding looks like. It looks like this spillway on Mars, not like this canyon in Arizona.
So science cannot prove a young or old universe, okay? However, even when we make uniformitarian assumptions, most age estimates are consistent with biblical creation, but not with the Big Bang story. And what I mean by that is uniformitarian is wrong. We're going to see some evidence that it's wrong.
Yep, everyone has been on board with that for decades. Once again, a creationist decides that he should criticize a strawman version of decades-old science. Will wonders never cease?
But even if we, for the sake of argument, make assumptions that are generous to uniformitarianism, generous to the Big Bang, generous to evolution, nearly all of the maximum ages for these space objects are much too young for the Big Bang story.
When will creationists realize that things in the universe do not need to be as old as the universe, and that finding young things in the universe doesn't make the universe young? Most of my audience are mammals, and mammals have hair, and hair grows from follicles, and sometimes follicles get infected. When this happens, it's often called a pimple, or a zit. I'm going to go out on a limb and guess that every human in my audience has had at least one pimple. Interestingly, though, they are all also older than any of their pimples. It's almost like new things form on older things.
But because these are maximum ages, the true ages could be just 6,000 years.
I'm going to guess before even hearing these arguments that they are all going to give minimum ages for the universe instead. Let's see if I'm right, shall we?
So, as an example, we're going to see evidence that spiral galaxies, secular scientists claim they're billions of years old. The Milky Way galaxy is supposed to be around 13 billion years old. But we're going to see indications that they can't be anywhere that old. That you're at an upper limit might be a few billion, maybe 5 billion years, or 300 million. There's a range there depending on the assumptions we make, but you've got pretty much a hard upper limit of a few billion years.
That sounds like a big problem. I sure hope it's not going to be based on not knowing what spiral arms are.
And so that's a contradiction with the Big Bang story. Okay, but that's a maximum upper limit, so could the true age be just 6,000 years? Yes.
Assuming we take this argument in isolation, and that it's correct, then yes, the problem is that we still have that pesky problem that we couldn't see any galaxies or even all of our own unless God is lying to us by making light from distant stars that never existed flying towards us. Or if the universe is old, much older than a few million years.
Now, one of the questions that always comes up when you're having this discussion is, what about distant starlight?
Oh yeah, I just mentioned that. He's right. That does always come up.
You've got galaxies that are billions of light years away, and since a light year is the distance traveled by light in a year, presumably, the argument goes, it would take billions of years for that light to reach us.
Yep.
Now, this is something that creationists are still working on, but I want to show you this issue is not quite as simple as everybody makes it out to be.
Maybe not, but it precludes a young universe as a possibility until creationists can come up with an explanation. And no, Jason Lyle's idea that maybe geocentrism is true actually, but only for light, isn't going to cut it. Because on its own, that requires a miracle, and those are not part of science, even if they are real.
The behavior of light is really strange. Okay, it's the speed of light is always 186,000 miles per second, and it doesn't matter whether the light source is standing still, moving toward you, or moving away from you. Now, if you think about that, that is very counterintuitive. Okay, that completely contradicts our common sense understanding of the way velocities should add and subtract. Okay, but that thinking is what led to this fact that light behaves in this weird way. That's one of the things that led to Einstein's theory of relativity, in particularly his special theory of relativity. And that's where you have these weird effects where clocks can tick at different rates depending on differences in speed and gravity.
Okay, but that's the problem. Like, he must see that that's the basis of why distant starlight precludes a young Earth universe without a liar god. If the speed of light were not constant in all observations, then it would be no problem for starlight to be distant. Just say it's faster out in deep space or something. No problem.
So I'm arguing that it's a mistake to reject biblical creation because of this issue.
Well, I hope we get more than just stating why it's a problem and then moving on.
It's something we're still working on, although some creation scientists think the problem has already been solved in principle, but it's not something that's easy to explain. So the first point here is that the speed of light's really weird, okay? So this is not going to be as simple as everybody thinks it is.
It's pretty simple. Light is always observed to move at a certain speed. If the universe is x years old, then we can't see farther than x years times the speed of light in distance. If the universe is 6,000 years old, then we can't see more than 6,000 light years. We can see more than 6,000 light years, so the universe is older than 6,000 years. If creationists have new physics to dispute Einstein, good luck to them. But this once again places them in the same boat as flat earthers, who also tend to reject relativity because it's inconvenient for their worldview.
And that weirdness led to relativity theory, and a lot of creationists think that the correct solution to this question involves relativity theory in one form or another.
Except that relativity is what raises the problem. It's like a doctor telling you that your blood pressure is too high because you smoke too much, so your solution is to just smoke more.
And furthermore, the Big Bang also has versions of this problem. It's got at least two versions of this distant light travel problem that creationists also have.
Except that unlike the problem that creationists have, these problems, 1, have a physically plausible mechanism to explain them, and 2, don't preclude a Big Bang. Unlike young Earth creationism, this is once again confusing an open question with a problem for the overall idea.
So I'm arguing that it is a mistake to reject biblical creation just because of this one issue.
And I am arguing that in the absence of a solution, it is in fact logical to reject young Earth creationism, because I won't give it the title biblical, since the people who reject young Earth creationism in favor of other ideas while remaining Christians are not simply ignoring the Bible. Young Earthers still don't have a monopoly on Bible interpretation or a sincere belief in the Bible as the Word of God.
I think when we look at the preponderance of evidence, it clearly favors a recent creation. It doesn't prove a recent creation, okay? Because again, you always have to make these assumptions about the past. But I think we're going to see that these give us hints that the universe is much younger than we're being told.
Can we actually get to the point where we hear this alleged evidence instead of being told that it totally exists, you guys? Trust me, I'm being totally serial.
And finally, I want to point out that biblical young universe assumptions have allowed a creation physicist, not me, but someone else, to make a bunch of successful predictions about the magnetism of bodies in our solar system.
Fascinating.
You may have heard people say that creation scientists never make predictions.
I don't say that. I just say that the ones they make that are different from what everyone else makes seem to always end up being false. But I'm happy to reconsider.
Well, we're going to see that that is not true in this discussion this morning. So we're going to start outside our Milky Way galaxy, and we're going to take a little tour of the local cosmic neighborhood, and we're going to zoom in and fly into our solar system. And our sun, like other stars, supposedly, according to the evolutionists, formed from a rotating cloud of gas and dust. And there's a lot of problems with this idea. We mentioned one of them earlier. They call this the nebular theory. It's changed a lot over the years.
Imagine that, a scientific theory that actually has to change in the face of new data. Creationists wouldn't know anything about that, would they?
But one big problem with it is that it may violate an important rule in physics called conservation of angular momentum.
All right, let's see it.
And Neil deGrasse Tyson, who is no friend of the creation movement, said a number of years ago, the scary part is that if none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons why stars could never form.
Let's read some of the context of that quote, shall we? Although I'm sure it won't actually be a statement about how stars do in fact form, because when have creationists ever been dishonest with quotations? Not all gas clouds in the Milky Way can form stars at all times. More often than not, the cloud is confused about what to do next. Actually, astrophysicists are the confused ones here. We know the cloud wants to collapse under its own weight to make one or more stars, but rotation as well as turbulent motion within the cloud work against that fate. So too does the ordinary gas pressure you learned about in high school chemistry class. Galactic magnetic fields also fight collapse. They penetrate the cloud and latch onto any free-roaming charged particles contained therein, restricting the ways in which the cloud will respond to its self-gravity. The scary part is that if none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons for why stars could never form. Okay, so here Tyson is laying the framework for the problems in stellar formation. The next couple paragraphs read thus. Like the Milky Way's several hundred billion stars, gas clouds orbit the center of the galaxy. The stars are tiny specks, a few light seconds across, in a vast ocean of permeable space, and they pass one another like ships in the night. Gas clouds, on the other hand, are huge, typically spanning hundreds of light years. They contain the mass equivalent of 1,000,000 suns. As these clouds lumber through the galaxy, they often collide with one another, engaging their innards. Sometimes, depending on their relative speeds and their angles of impact, the clouds stick together like hot marshmallows. At other times, adding injury to insult, they rip each other apart. If a cloud cools to low enough temperatures, less than about 100 degrees above absolute zero, its constituent atoms will bump and stick rather than careen off each other, as they do at higher temperatures. This chemical transition has consequences for everybody. The growing particles, now containing tens of atoms, begin to bat visible light to and fro, strongly attenuating the light of stars behind it. By the time the particles become full-grown dust grains, they contain upwards of 10 billion atoms. At that size, they no longer scatter the visible light from the stars behind them. They absorb it, then re-radiate that energy as infrared, which is part of the spectrum that freely escapes the cloud. But the act of absorbing visible light creates a pressure that pushes the cloud opposite to the direction of the light source. The cloud is now coupled to starlight. The forces that make the cloud more and more dense may eventually lead to its gravitational collapse, and that in turn leads to starbirth. Gee, who could have predicted that, in fact, Tyson was reporting how a star can form and using the physical challenges that act against this as a rhetorical device to show how cool it is that it can happen anyway, following well-understood laws of physics. It's not normally this early that I come to the conclusion that the creationist is lying, but a blatant quote mine will sure do it. Can we toss Jake the Forehead Hebert on a pile of liars for Jesus along with Kent Hovind, Andrew Snelling, Robert Carter, and John Sanford?
So it is very tough to explain naturally, apart from a supernatural explanation, how you can have trillions of stars in the universe.
Or, you could just read the next 3 paragraphs in Tyson's book, and sure, maybe you think that the explanation is insufficient, but then at least you could explain why instead of just lying to the audience.
Now, our star is very well behaved. It shows evidence of design. There are other stars similar to our sun that can emit big blasts of radiation once a century.
And there are others that don't. What about this makes the sun seem designed? Also, it's not really all that surprising that humans find themselves near a star that wouldn't preclude their existence, since how could they find themselves anywhere they couldn't exist? If life, and specifically humans, came about through natural processes, they obviously would have done so in a location that allowed for it, not one that didn't.
What you call super flares. Now, our sun has flares too, but those flares are mild, and it's a good thing that God designed our sun that way, because otherwise we would be in a lot of trouble.
Odd how he hasn't even begun to argue that the sun is designed, or given criteria by which we could distinguish a design star from a non-design star.
Okay, if one of those super flares happened on our sun, let's just say it would ruin everybody's day. Okay, so our sun, it shows evidence of creation, evidence of design. And I'm going to argue that the idea that it's billions of years old actually presents problems for the evolutionary story. There was a famous solar physicist named John Eddy. He studied the sun.
That is what solar physicists do.
And he made some waves a while back when he said that he thought astronomers could live with an age of 6,000 years for the Earth and the sun. Now, he was an evolutionist. He believed the sun was billions of years old, but he said, as far as the actual astronomical evidence is concerned, he thought an age of 6,000 years was reasonable.
Here's a fun fact. That quote only exists on creationist websites as far as both myself and the contributors to Tark Origin can tell. Because, being reportedly from 1978 is well old enough for it to appear on that repository of knowledge. The interesting thing is that this is a quote mine of an apparently made-up quote, because the beginning of it presents the shrinking diameter of the sun as a problem for the 4.5 billion year age of the solar system. The problem is that since then, the astrophysicists have discovered that in fact the sun is not meaningfully shrinking in some constant long-term manner, as was suspected in the 1970s. So Jake here is quote mining an apparently invented quotation from 45 years ago that itself relies on now disconfirmed ideas about the sun. Nice. That's exactly what I've come to expect from creationists.
Also, the idea that the sun is billions of years old, it actually presents a problem called the young faint sun paradox. And it's kind of ironic, but it was the late Dr. Carl Sagan who was one of the first people to point this out.
It's only ironic if you, like Jake, project your dogmatism onto Sagan. Sagan wanted to know what science had to say about the universe. The fact that he didn't know everything didn't scare him off from trying to find out so he could just say that a god did it, or so he could just pretend that there wasn't a problem to be solved. That's the domain of pseudoscientists.
He was always trying to convince us that the universe is billions of years old. But he realized that based on ideas about how stars slowly evolve over billions of years, he realized that billions of years ago, supposedly when life was just getting started, the sun would have been about 30% dimmer than it is today. Now, the problem with that is that would mean that the Earth was getting a lot less sunlight, and that means the Earth would have frozen.
Yeah, but only if you ignore things like the greenhouse effect. That's it, that's all it takes. There was more methane and CO2 in the atmosphere then than there is now, so Earth retained more of the heat that it got. This so-called problem isn't really a problem and hasn't been for a while. Now, exactly what the atmosphere and planetary albedo were like is still up for question, but the idea that the Earth couldn't possibly have had liquid water billions of years ago because the sun was too faint is simply no longer a problem. Instead, we have an abundance of solutions, and we had to figure out which one contributed most.
Now, the problem is most evolutionists think the Earth was warm at the time that life was supposedly getting started, and therefore you have a contradiction where one part of the Big Bang story is contradicting another part.
Well, no, we don't, but neither of those are the Big Bang. Jake has 3 degrees in physics. I do not for a second believe that he doesn't know that stellar formation, planetary formation, and the Big Bang are not the same thing. He's intentionally conflating them so that if he can poke holes in basically any part of astrophysics that uses deep time, he can thereby convince his audience that this therefore pokes holes in all explanations using deep time. It's dishonest. I once again, perhaps in vain, ask any creationist watching this to explain to me why, if your ideas are true, it's so easy to catch your so-called experts in blatant lies.
And they call this the young faint sun paradox. Now, every now and then you will see headlines in the science media claiming they've solved this problem. Here's one from 2010. But then they pointed out the next year, oops, well, no, actually we didn't solve it after all. Here was another trial balloon in 2013, but they're still working on it back in 2016. So you get the idea, okay?
Odd that the last cited work is from 2016, some 7 years ago or so. Perhaps because in more recent times progress has been made in things like overcoming earlier problems with greenhouse gas escape to space, causing proposed solutions to not be adequate. Papers just this year, like Adams 2023 and Walter et al. 2023, have noted there are potential geological sources for greenhouse gases during early Earth that can offset potential loss to space during the early epochs of the Sun evolution when it was significantly cooler. In fact, we know that water flowed on Mars, so we know that planets can gain and lose atmospheres sufficient to allow for warmer than might be expected climates. But yes, there are still questions to be answered about the faint young sun. But remember, there being some open questions about the history of the solar system doesn't really negate all the rest of astronomy. On the other hand, creationism has that heat problem that among myriad other problems physically precludes the flood as modeled by young Earth creationists, which is a bit of a problem that, as far as I can tell, no one has even pretended to solve outside of just attributing it to a miracle, taking the whole thing directly outside the realm of science.
They claim to have solved this problem, but no, they really haven't.
I will agree that some reporting on this work in the past has been overly optimistic about the proposed solutions.
Okay, and so that's an indication that our sun is younger than what they're claiming, because you don't expect the brightness of the sun to change that much over just a few thousand years.
Yeah, no one is disputing that.
Now we go to the innermost planet that's Mercury, and it may just be me, but I think the Lord's probably going to make us change the names of these planets when he comes back.
Oh no, the planets are named after Roman gods for the most part. Look, if it's sinful to call it Mercury because that's the name of a pagan god, creationists could just start calling it Gabriel or something. They don't.
I just have a hunch about that, given that he is a jealous god. But Mercury has indications of youth. It has a magnetic field. Now, why is that a problem if you believe in billions of years?
Current models of Mercury's formation do not in fact predict that it should be entirely solid, and it evidently is not. But it is much more solid than Earth, accounting for the fact that the intrinsic field strength of Mercury's magnetic field is about 1.1% that of Earth's.
Secular scientists think that a planet or moon has to have a molten core in order to have a magnetic field. Now the problem is when you have small bodies like Mercury or the moon or whatever, they lose heat relatively quickly.
All things being equal, yes, but things are rarely equal, and Mercury has a particularly elliptical orbit with an eccentricity of 0.205630. As an explanation of eccentricity, 0 indicates that an orbit is a perfect circle, and at an eccentricity of 1 the orbit is no longer closed and is a parabola, meaning that the body in question is not actually orbiting the mass in question in equations to calculate orbits. For example, Oumuamua is an extrasolar body that passed through the solar system and was shown to have an eccentricity of about 1.2, which is why it was known to not truly be in orbit of the Sun, but rather to be passing through. Earth's eccentricity is 0.0167. As a result, this means that Mercury's orbit is more than 12 times as eccentric as Earth, and being much closer to the Sun, more than 2.5 times as close in fact, means that it gets huge tidal forces, which even in a small body can cause large amounts of internal friction. Another spectacular example is the Jovian moon Io. It is famously the most volcanically active body in the solar system. It is more than 3.5 times less massive than Mercury and more than 15 times farther from the Sun, meaning it gets about 0.4% of the solar radiation that Mercury does. How does it get all the heat that is needed to melt the mostly silicate materials Io is made of into lava? Why, tidal heating, of course.
So secular scientists were completely surprised to find that Mercury has a magnetic field because it should have cooled off billions of years ago and it should no longer have a molten core.
It was actually more about misunderstandings of how an atmosphere affects things, and with a field strength of just over 1% that of Earth's, Mercury only barely has a magnetic field anyway.
Okay, that's the problem. So this looks like Mercury is young.
Only when you pretend that tidal heating isn't a thing.
And Russ Humphreys, he's a creation physicist who's done a lot of work on magnetism.
You are technically correct. The best kind of correct.
Both here on Earth and in outer space. He predicted back in 1984 that older volcanic or igneous rocks should contain a record of past magnetization. Well, guess what? When the Messenger space probe flew by Mercury, sure enough, there was evidence of magnetism in these rocks that were thought to be quite old. Now,
what? No, that's not at all what Humphreys did. Humphreys created a model in which he assumed that God created all the planets and the sun as pure water, then later alchemically transmuted them into not water. But this water had a significant fraction, which he calls K, of its molecules aligned so the dipole moment of the water molecules added up to a substantial magnetic field proportional to the mass of the planet and this K value. It should be noted that there is no natural way to align water molecules this way, nor is there a natural way to transmute water into things like iron, silicates, or hydrocarbons, nor is the value of the variable K constrained other than that it must be between 0 and 1. Meaning that not only is this model completely unscientific, as it has no plausible mechanism, but also it predicts the magnetic field strength of any planet or moon with such a huge range of possible values, which always includes 0, by the way, that virtually any measurement would be predicted by this model, meaning that it really predicts nothing. His prediction wasn't about paleomagnetic traces in the rocks of planets. That's something that science predicts too, and it's also not what was actually measured in various planetary flyby missions that measured magnetic fields.
we don't accept that age estimates of billions of years, but these radioisotope dates can be correct in a relative sense, though not in an absolute sense.
Only if you reject the basic principle of science that physics is just physics.
Russ Humphreys also predicted that there would be a significant decrease in what we call the magnetic dipole moment of Mercury. Now, that's just a number that tells you how big the biggest part of the magnetic field is. And he didn't get this exactly right. He actually underestimated a little bit. It actually turned out to be 8%.
No, it actually turned out to be that the measurements of Mercury's magnetic dipole were in fact within each other's margin of errors, meaning that there was no demonstrable change. And the amount that Humphreys indicated in his assessment of the data was more on the order of 40%, which, is kind of a lot, and would indicate that just a few hundred years ago, Mercury should have been rivaling the Sun in terms of magnetic field strength, or that it was recreated as water recently, or some other such implausible thing. You see, Humphreys' idea, since model is too generous, requires exponential decay of all planetary magnetic fields, because they were initially set up the same basic way as a permanent magnet, that is, by aligning the dipole moment of molecules or atoms. This kind of field must decay exponentially, and Humphreys predicts that it will decay at more or less the maximum rate, because it is only maintained by the counterflux it itself induces during collapse. He based this on the fact that he had access to about 150 years of magnetic field strength data for Earth, and that it showed decay in Earth's field strength. Of course, since then, paleomagnetism has shown that no, Earth's magnetic field isn't just decreasing from some previous much stronger value. In fact, it fluctuates and reverses. So Humphreys is simply wrong, and the fact that his model, which had almost unlimited ability to accommodate measurements of magnetic field strength, which allowed him to say he predicted the field strength of various planets, doesn't really help.
But remember, secular scientists didn't think Mercury would even have a magnetic field at all, let alone one that was changing so rapidly.
Well, again, there's no evidence that it's changing at all, never mind rapidly.
Now we're going to go to a visitor to our inner solar system, a comet. And of course, you know that comets are these dirty snowballs, and every time they come near the sun, these ices on the comet nucleus vaporize and form these beautiful tails. So every time they come near the sun, they're losing mass, and so they're kind of like melting ice cream cones. Now, secular scientists claim these are leftovers from the formation of the solar system 4.5 billion years ago. Well, why then do we still see these comets? They have finite lifetimes. Why do we still see them?
Because most comets never come close to the sun and instead stay well beyond the frost line, which is the distance from the sun at which solar radiation cannot heat ice above its sublimation temperature, meaning that actually most comets have an indefinite lifespan. However, gravitational interaction will sometimes kick comets into lower orbits, resulting in comets that have a perihelion, or closest approach to the sun, that is within the frost line, which causes them to lose mass each orbit.
Now, they're aware of this problem, but they would claim that these comets are being replenished by these reservoirs of potential comets. And because the different comets have different orbital characteristics, they need more than one reservoir. One of them they call the Kuiper belt or the scattered disk, and there's another one that they call the Oort cloud.
The Kuiper belt definitely exists. We know of many of the larger and even some of the smaller objects in it, such as Pluto, Charon, Eris, Sedna, and Ixion, as well as hundreds of smaller bodies that don't really have a name, more of a catalog designation. Now, because big bodies are the things that are easiest to find, we have a bias towards finding the largest bodies in the Kuiper belt. But as we have recently discovered with the 2 new moons of the Pluto-Charon system, we know that there are, in fact, also smaller objects that are sizes typical for sun-grazing or short-period comets.
And there's problems with this idea. For instance, these comets that are thought to be what they call Halley-type comets, they thought, well, maybe we can explain them by the scattered disk, okay, which is a part. It's these bodies that are part of what they call this Kuiper belt. Well, they realized there's not enough mass there to make that work. So they thought, okay, well, what about the Oort cloud? Maybe the Oort cloud could be the source for these Halley-type comets. Well, the problem with that is that even as Carl Sagan acknowledged, there's no direct evidence that the Oort cloud even exists.
That's true. The Oort cloud has never been directly observed. But what does that actually mean for its existence? Well, not much really. So let's take a look at the discovery of Neptune. In 1821, Alexis Bouvard noticed that Uranus's orbit was not what would be predicted by Newton's laws. Unless, of course, there were another massive body at a more distant orbit that were tugging on Uranus from time to time. No one had ever seen this planet, with the possible exception of Galileo, who saw what he thought was a fixed star, but he saw it in the place where Neptune would have been, so maybe that's what he saw. Either way, he didn't identify it as a planet, and it wasn't until 1821 that anyone thought there was another planet past Uranus. It wasn't until 1846 that Neptune was first observed definitively. That means that for about 25 years, people knew that there was almost certainly a planet beyond the orbit of Uranus, but they had not observed it. Yet there it was. Because the law of gravity isn't some mystery, even less so now that we have Einstein's even more accurate equations which explain things like the precession of the orbit of Mercury. So what makes astronomers so confident that there is in fact an Oort cloud? Well, let's look at the very paper that Jake cited. That is, An Oort Cloud Origin of the Halley-type Comets by J.H. Wang and R. Brasser, published 20 March 2014 in Astronomy and Astrophysics, link in the description. There are 4 major families of comets based on their orbital characteristics: Jupiter family comets, Halley-type comets, long-period comets, and Oort cloud comets. Now, the paper argues that Halley-type comets are actually formerly long-period or Oort cloud comets that interacted gravitationally with Jupiter or Saturn, lowering their aphelion or highest distance from the Sun, from approximately 10,000 astronomical units, or AU, to their typical apelia of less than 34.2 AU. In case you're not familiar with that unit, an astronomical unit is equal to the semi-major axis of Earth's orbit around the Sun, which is also the mean distance of Earth to the Sun. Although, since Earth's orbit isn't a perfect circle, the math is a bit more complicated. I am not here particularly interested in Halley-type comets per se, but let's look at the long-period comets and the Oort cloud comets. They all have apelia that are around 10,000 AU, roughly where the Oort cloud is predicted to be. And why is this predicted to be there? Well, because without an Oort cloud, how the heck did so many comets end up with apelia that are of about the same value? There really isn't a great answer. And remember, these orbits are calculated the same way as the orbit of Neptune was calculated. Further, Oort cloud comets are themselves first-timers in the inner solar system, meaning that we have indeed watched new comets come in from the Oort cloud. Combined, the observed advent of new comets and the consistent apelia of long-period comets leaves very little doubt that there is an Oort cloud, just like the orbital oddities of Neptune left very little doubt that there was another planet out there.
Okay, so there's all these problems with these ideas. They don't work very well.
Actually, orbital mechanics work quite well, and the fact that we don't currently have an image of a tiny speck of ice and dirt from 10,000 AUs from the Sun isn't really a problem. In fact, it's to be expected given how faint such objects would be.
In fact, we actually see evidence from individual comets that they're very young. Comet Hartley 2 is still outgassing carbon dioxide.
This is not an indication that the comet is young, rather that it has only recently started going below the frost line in its orbit. Essentially, it is a very old comet, but it has not been a sun grazer for long.
And secular scientists were shocked by this because they thought, if this thing is 4.5 billion years old, all of this volatile CO2 should have vaporized a long time ago.
Yeah, that's what Space.com said, but I can't find any evidence of controversy over the age of the comet anywhere in the actual peer-reviewed literature. It looks like this isn't actually causing a stir among anyone studying this comet. And you'd think that as a physicist who is concerned with this topic, maybe Jake would keep up with the literature so he could cite a peer-reviewed paper on the topic, rather than Space.com, like he has for other claims. Weird that he hasn't. I'm going to have to say at this point that this is just not something actual scientists find puzzling, and instead it's just something that the author of this article, for non-specialists, found puzzling. And further, I'll note that she did reach out to experts for their take on other parts of the article, but not this part.
They said it was inexplicable as to how this comet could still have carbon dioxide in it.
Who are they? Because the only person I can find saying this is Natalie Walchover, the author of the Space.com piece. And while I am in no way attempting to disparage her, let's remember that her highest degree is a physics bachelor, and she does not seem to have consulted any actual subject matter experts on this particular topic. So while she might think this, or more accurately, did think it some 22 years ago, that does not make it an actual problem for current models of comet formation and migration. If you want to claim that experts are puzzled by something, and that the thing therefore is a problem for their models, you have to, show some of the experts being puzzled.
But it's a lot easier to explain if that comet is much younger than they're saying, if it's just thousands of years old.
Yeah, but that would contradict basically all the data we have on the age of the solar system. So while that might work to explain this particular comet, it doesn't work any worse than the standard model, and the standard model has the advantage of also being consistent with all the other data we have about things like the age of the solar system, the age of the Earth, the age of the universe, the nebular hypothesis, standard models of stellar formation, etc.
Now we're going to go to Venus, and Venus spins backwards. That's a problem for the secular story.
Is it, though?
Because if you say that the solar system formed from a rotating cloud of dust and gas, everything ought to spin the same way.
Yeah, if you stop studying physics in high school, maybe that works. This is about the conservation of angular momentum. You can kind of think of angular momentum as how much a system is spinning. Now, if we ignore friction, which is especially reasonable in space, then an isolated system must maintain its angular momentum at a constant value. You can see this happening when a figure skater starts a relatively languid-seeming spin, only for them to start spinning furiously simply by bringing their limbs closer to their body. As the distance from the center of the spinning decreases, in order to preserve angular momentum, the spin rate must increase. Because, just like with linear momentum, the distance moved per unit time is an important part of angular momentum. Now, as you might expect, if you add angular momenta together, opposite spins are treated as opposite signs in math, so negative and positive. Which means that relative to the spin of other planets, Venus's spin is negative. That's why its rotational period of 243 days is sometimes given as a rotational period of negative 243 days, to emphasize that it's spinning opposite the normal direction. Okay, but let's try some math here. Here's an equation. 2 plus 2 equals 4. Simple enough. But now let's say that I want to manipulate the left-hand side of the equation by putting in a negative number, but also want to keep the right-hand side equal to 4. Well, if I say add a negative 2 to the right-hand side, if I also add an additional positive 2, it works out. So if I say negative 2 plus 2 plus 2 plus 2 equals 4, that still works out. And this gives us our clue as to how things can orbit or spin backwards in the solar system without violating the law of angular momentum. You see, both gravitational interactions and impacts cause bodies in the solar system to exchange angular momentum. So for Venus to spin backwards, all that has to have happened is that it added to the angular velocity of the system as a whole, and this was probably done via massive impact early in Venus' existence. Similarly, the few moons in the outer solar system that orbit their host planets backwards were probably captured gravitationally, and in so doing, added to their host planet's angular momentum, albeit in such minuscule amounts that we could probably never measure it. In fact, this same effect is how NASA uses gravity assists to both raise and lower the orbits of space probes to save on the otherwise prohibitive fuel costs it would take to get probes to places like Saturn or Pluto. So no, there's no problem with Venus spinning backwards.
Well, Venus doesn't, and so that's a problem for the secular story.
Yeah, because scientists are under the impression that objects in space never collide or interact gravitationally, right?
Moreover, there are recent lava flows on Venus, and the cratering is uniformly distributed. There's not that much of it. That's an indication of relative youth for the surface of Venus.
Yep, sure is. Hey look, there's a spider molting. Now it has a new surface. I guess that means that the spider is only as old as its last shed, right? Oh, wait, it doesn't mean that? Spiders can replace their surface many times in their lives? Darn. I guess this is just a dumb argument then.
Now, secular scientists still would say this is maybe 700 to a billion years old, but they would argue that something catastrophic happened to repave the surface of Venus in the billions, maybe 700 to a billion years ago.
By something, he means volcanism. Remember, Venus isn't much smaller than Earth, and so like Earth, it presumably has a liquid outer core and a flowing rocky mantle, meaning that it has volcanoes. The big difference between Earth volcanism and Venus is that on Earth, volcanoes go off here and there more or less all the time, but it seems like Venusian volcanism tends to happen all at once on a planetary scale. That volcanoes exist on Venus and have done things is in no way an indication that Venus is young. Please remember that one of the reasons that Jake thinks this indicates a young Venus is the relatively even and sparse impact cratering on Venus. Which I mean, okay, but then what about the heavy cratering on Mercury or the Moon? Surely that must indicate that both these bodies are very old. Oddly enough, he doesn't think that. It's almost like there's no internal consistency in these arguments.
Now, they don't like that. This planetary scientist said he doesn't like uniformitarianism. Remember, we talked about uniformitarianism earlier, but he said, I don't know how to explain this apart from a catastrophe.
Cool. Uniformitarianism has been replaced by actualism for a while now. Scientists are not afraid of invoking catastrophes when the data warrant it. They're just not willing to do so when the data do not warrant it, or even preclude it, which is why they're perfectly happy to explain flood spillways on Mars with cataclysmic floods, and the resurfacing of Venus on massive volcanism, but reject a worldwide flood. The data support the former two and preclude the last one.
Now, why is it that secular scientists are so averse to catastrophism?
They're not. I mean, maybe they were in 1995, but they really aren't now, and it's a bit harder to make neat predictions with catastrophes. So if you can avoid using one, you're usually better served avoiding a catastrophe in your explanation. But still, catastrophes are all over the place in science, from the formation of the moon to the death of the non-avian dinosaurs.
Well, I'm going to argue that it's because if you need catastrophism to explain the geology on Venus, you may need catastrophism to explain the geology on Earth.
You do. Catastrophes of various scales are a standard part of the explanation for some features on Earth. But that some catastrophes have happened is not evidence that your particular, otherwise unevidenced, and even precluded physically impossible catastrophe of choice also happened. However unfortunate it is, a cousin of mine was murdered in her 20s. The murderer was a paranoid schizophrenic who thought that she was dating his brother because she was a government agent sent to spy on him. This fact doesn't mean that I get to go around treating everyone with schizophrenia as a murderer, especially since most of them never have and never will murder anyone. And I'll be honest, I struggle with that, and it's probably why I should never be seated on a jury for a case like my cousin's. Similarly, the fact that there are some catastrophes on Earth, Mars, and Venus is not a good reason to look at any alleged catastrophe and just accept it. Most hypothetical catastrophes didn't occur. In fact, there are an infinite number that didn't occur. In order to say one did, you need evidence. Just like I need evidence to say that any given person with a particular psychological order has killed someone. Sorry, it got a bit dark there.
And what if there's geological evidence that that catastrophe involved lots and lots of water and sounds an awful lot like the Genesis flood?
If there were such evidence, then it would be the scientific consensus. There is no such evidence.
I think that will go a long way to explaining why they are so averse to this idea of catastrophism.
No, it doesn't. No one is out there trying to disprove the flood of Noah. It's just that ever since the beginning of geology as a rigorous field, no evidence in support of it has ever been found. And so now people have mostly stopped looking for it. Geologists are no more attempting to disprove the Genesis flood than astronomers are trying to disprove geocentrism or cartographers' flat Earth.
Now we go to the third planet from the sun. Hopefully everybody recognizes this one. This is our home Earth.
Geez, that Earth looks terrible. Look, here's a surprise Blender tutorial on how to make a good Earth in like no time at all that you can rotate, zoom in on, whatever you want. And it'll look way better than this. And helpfully, you can also easily swap it out for other planets quickly by just changing a few things. Alright, here we are. We're in Blender 3.6. First things first, let's get rid of the default cube. We don't need it. We'll add some kind of mesh to hold our geometry nodes. Let's pick a cube. Go to geometry nodes, new. Disconnect this, we don't need it. We're going to add in a UV sphere, that's F3 to search. And then we're going to put this right here, rings, into here. Hit N to bring up this side tab here. Change this to resolution. There we go. Math node. Set this to multiply, set this to 2. And this is going to come in here. Now we can change the resolution of our sphere. So as we slide this up, oh, the sphere gets much, much nicer. Okay, cool. We're getting actually pretty close. Next up, we need a transform geometry node. Boom. And then we're going to need another one. This is just going to go up here. Next up, we're going to add in another input. We're going to call this one scale vector. Okay, and we're going to change it from integer to float. So, next thing we're going to do is add in another math node. We're going to set this to divide. Set this to some high number. It doesn't really matter. It's just so that your scale factor is easily controllable rather than just going crazy. So we're going to set it to 1,000. Then we're going to add, so another math node, add 1. So it starts at 1 even if the float value is at 0. Also, we're going to set the minimum to 0, so you can't go below 0. I'm going to set this into this scale, and then also into this scale. Next thing we need is a geometry, join geometry. We're going to put in the original UV sphere, as well as both of these outputs. This gives us 3 concentric UV spheres with controllable resolution. So, if I up this scale factor, you'll start to see them separate. Awesome. We don't want this very high, but we do want the resolution pretty high. So we're going to change this to 64. Okay, and we have a few more things left to do. We're going to add in a set shade smooth. I'll just smooth out all these spheres. And then for each of these spheres, we're going to be setting a material. So, also we don't need this geometry input, so let's just get rid of it. Okay, so we're going to set material. And then we're going to bring this material back here to the input. We're going to call this atmosphere. Okay. Put in another one. Set this down here. Whoops. Put it down here. We're going to call this clouds. Cool. And then one final one. Put this down here, and we're going to call this one surface. Surface. Okay, so now we're going to go over to our materials, get out of the geometry nodes layout. We no longer need it. So over in materials, we're going to add in a new material. We're going to call it atmosphere. And we're going to add in another one. We're going to call it clouds. And then we're going to add in another one. We're going to call it surface. Now this is the cool thing. If you have this all set up this way, and you have other shaders that you want to bring in to represent, say, Mars or Saturn or Jupiter or whatever, you can just replace these materials with the appropriate ones. But I'm going to show you how to set up one for Earth. So back over to our modifiers. Set this to atmospheres, because apparently I spelled it wrong. I don't care. Clouds and surface. Back over here, we're going to drag out a materials thing here. Okay. We're going to start with the atmosphere, or atmospheres, whatever. Add in a layer weight node. We're going to put it on facing. I have node wrangler enabled. That allows me to shift control and cycle through these. Also, we're going to switch this to look dev so we can see what the heck's going on here. I'm going to up this blend just a little bit. That seems fine. Oh, great. There's a thunderstorm. Maybe you'll hear lightning. I don't know. Okay. And then we're going to actually set this right here to a sort of atmospheric hazy color. And set this to alpha. We're actually going to switch over to rendered view. Switch our render engine to cycles. This will work better. Okay, so now you can see that there is a faint blue haze all around this. Now, the scaling factors may be a little big. We can fix that later. That's not a big deal. Okay, so let's go to clouds. Now, for these, I have downloaded image textures from NASA. So, image texture. And I need to go to my Blender files. Search for planet, which is where I keep them. Okay. And here we go. We got our 8K Earth clouds. So just plug this into the alpha, and nothing happens. That's because this is set to flat. Set it to sphere. There we go. Now, just for demonstration purposes, I'm going to turn this to just be kind of just all black. Okay. So set that was Control T to get this. Put this on object mode, and boom. We got some of that going on. A little bit of stretching here and there. Why is that? Because it's not ungenerated. That's why. We do want it ungenerated. Okay, so now we've got the cloud set up. Now, if we want to, we can be a little bit extra fancy with this. Set it back to here. Let's bring in a bump node. Set its height. Let's put our strength down pretty darn low. Set it to, there we go. And there you go. Now, near the Terminator line, you'll get a little bit of bump on the clouds. Not really a big deal. Anyway, let's go to surface. So, we're going to add in image texture, just like before. This time we're going to do a few more, though. So we need this Earth 8K day map. Boom. Then we also need to Control T, set it to generated, and set this to sphere. There we go. Now, that doesn't look great. So we need more maps. It's all about the maps. We need a specular map. So we're going to put the vector back in here. It's already set to sphere. Set it to non-color because this is not color data. And then we're going to get in a map range node. So first, one of the things you want to notice is that this is a black and white image where the land is black and the ocean is white. That is because this is set to specular, not roughness. We need to reverse that, and we also need to be able to set our values. So you can drag this down, get a map range. Set this from vector to float. Plug it back in, because that's annoying. Come on, there we go. Okay, so I want this to go from, so it goes from 0 to 1, that's black to white, but I want to reverse that. So this is going to become a 1, and this is going to become like a 0.5. So that gives us this. This can go into roughness. Now this lower number controls how rough the ocean is. I want it to be a little bit more shiny, not quite that shiny. There you go. We're already getting to the point where this is basically probably better than anything that ICR is going to do. So let's bring this background color to 0. Yeah, that's doing pretty well. But let's make it better. Okay, So grab this light. We're going to change it into a sun lamp. Bring the strength down to like 3. It's a good rule of thumb for me. We're also going to clear its Z location or Z location, depending on where you live. Now, this doesn't do much really at all, but it does make it easier soon. So we're going to add in a empty plane axis, and we're going to scale it up. The scaling doesn't really do anything. It's just to make it easier to look at. All right, so we're going to right click to select. I have right click select. You might have left click select. Select on Earth, Shift select here, Control P. I like to just do keep transform because sometimes if you don't, it does wonky things. Doesn't really matter. There we go. It's still named cube. Let's change that. Earth. EARF. Earth. That's Earth now. Okay. So we're going to set this guy with a constraint to track to world space. World space is good. We're going to track it to the light. Okay, and then we're going to grab our light. Can't really see it, so we'll just select it here. Great. We're going to track to the empty. So now, no matter what, the empty will track towards the sun, and the sun will track towards the empty. That's not just useful for lighting, it's useful for a few more things. Make sure we're on surface. So here's what else it's useful for. I'm going to add in a gradient texture. I hit Control T on that. Okay. Shift Control on this because Node Wrangler is enabled. And let's see. We are going to, linear, we're going to put it on object, and we're just going to select with the dropper tool the empty. Pretty sweet, right? Okay, I'm going to hit 7 to go to top view, and I want to rotate this so that it actually faces the sun. Okay, so rotation, just fiddle with which one it is. Looks like -90. Okay, now we're going to add in a color ramp. One word for some reason. There we go. Shift Control on this again. I'm just going to move the black out just a little bit. Yeah, there we go. Okay, so next up, we are going to add in yet another texture. So let's grab these. Okay, we're going to add in Earth, 8K Earth Night Map. There we go. All right. Attach it here. It's already in sphere. Now, we got this, right? Okay, cool. So what we're going to do is we're going to combine this with this here to affect emission. So here's what we're going to do. We're going to plug this in to emission color. That's going to give us our emission color. We click back here. It's the same thing, except now you can see there's a subtle glow where the cities are. So it looks great back here at night, not so great in the daytime. That's why we have the gradient. First things first, invert. Okay, next thing we're going to do is we're going to take this down here. We're going to put it into a ramp, color ramp. Color ramp. Can I spell? No. Okay, toss it down here. We're going to bring the black up a little bit, bring the white up a little bit. And we're going to multiply these two together. So we got math node, math, whatever. Vector math, whoops. Just add a math node. There we go. Math, not add, but multiply. So the black bits come together and anything that's black on one is black on the other. Boom. Shift Control, take a look at this. Oh, hey, look at that. There's no glow on the day side, and there's glow on the night side. Put this into emission strength. And there you go. Now we got nice land that doesn't have any glow on this side. Land that does have glow on this side. And now it's a bit strong, so what I'm going to do is I'm just going to repeat this. And this is just going to be a brightness control now. So I'm going to set this to like, I don't know, 0.2. There you go. It's a little bit more reasonable. Okay, cool. Almost done. We're going to switch back over to atmosphere after we select all this. I'm hitting C for that selection. Go to atmosphere. Oh, forgot to copy it. Control C. There we go. We're going to Control V. I don't need this UV map here. Selected X only. Okay, so what are we going to do with this? Well, that's pretty easy. We're going to grab a mix color node. Now, we want the bottom one to be our blue color, and this is going to be our sunset color. So we're going to make this a little bit on the reddish side. Pretty red, maybe there. Okay. And then we're going to shift control to take a look at how this is doing. So this is the pure 50-50 mix. And I add this in as the factor, and you can see that this is now blue where it is towards the sun and reddish where it's not. But it's a bit extreme. So we're going to dial that blue back by pulling this white flag here back, and we're also going to pull this black flag back a little bit. Plug this into the base color, and boom, now you have a subtle sunset effect right near the Terminator. And yeah, there you go. A better Earth than ICR is ever going to give you.
71% of it is still underwater. Most of the land surface is covered by what we call sedimentary rocks, and even evolutionists acknowledge those are nearly always, almost always deposited by water.
Yeah, that almost is pretty important here, because some of them are not. And even some of the ones that are can't be deposited by a flood, because we can tell how much energy was in the water that deposited various kinds of sedimentary rocks. And much of the sedimentary record of Earth involves low energy systems, rather the opposite of a raging global flood. But you know what? That's it for today. Let's pick it up next time with more about geology, paleontology, and taphonomy. Well, if you enjoyed the video, hit like and tell me in the comments. If you didn't, feel free to hit dislike and tell me what the problem was, again in the comments. Either way, please remember to subscribe and hit that bell icon so you're always notified when I have more content. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tovind, Tapioca Weasel, Whispers, Elron Teller, Phil Havara, Ian Chen, Kelvin Brostick Van Manen, Landon Knoll, Mabbity Babbity, Monkey They Them, Mrs. Specsender, Sphincter of Doom, and the Venerable Bede. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.